Hello and welcome back to Refactoring Rose, where we take a 20-year-old app and modernize it with Swift and other tools. In this episode, we are moving to SQLite 2, changing the configuration of the database. Before we get started, this is an exciting time in the annual calendar for Apple. So, macOS Sequoia and Xcode 16 have been released. That has implications to our particular project. First, I've moved from Sonoma to Sequoia. And the biggest implication there is Xcode 16 and below are no longer supported. And you may have to do some particular weird things to get them to work if you need them. So that means if you're going to move to Sequoia, you probably need to go ahead and move to Xcode 16 and move your projects to Xcode 16. Xcode 16 brings a lot of interesting new things. And in particular, it's going to use AI-based autocomplete. There is going to be Swift Assist available later that's a bit more like things like Copilot. But right now, it's just going to be autocomplete. And the second big thing that's in Xcode 16 that I can think of is Swift testing, which is a new framework for doing your unit tests. But the big warning I have for you about Xcode 16 is that your CI/CD system may not be ready for Xcode 16 yet. So make sure before you make the move to Xcode 16 and Sequoia that your CI/CD systems are ready for Xcode 16, or if you're willing for it to not work for a little. If those conditions are met, then go ahead and go to. I don't think my CI/CD system for Rose is ready, but it's not really actively working anyway. So we don't really have that worry just yet. Okay, with that out of the way, let's go ahead and get into what we're doing. Remember that, as I've shown previously, SQLite has a very important role in Rose. It's right now the current file format, and it's also used in memory to manage information about the UI, manage the data tables imported by the user, and more importantly, allows users to cut and make different versions of their data sets so they can plot them differently. Now, long term, I might change how all this works, but right now we kind of still have to work with it. But as I mentioned, there's a big problem with it. And that is the system sort of looks like this, where we have all these objects directly talking to SQLite, starting from the NS document object all the way down to various models are talking directly to the database. Now, the problem with that is that it makes it very hard to make any changes to this system. All these objects should be talking to some abstract level and not know what the data, how the data is being stored, whether it's stored in a database, is stored in a data frame, or is it stored in just mutable arrays or something like that. We don't want that. We just want to have a very simple interface where all these objects can be talking to this interface and what's under the hood is being handled. So we want something more a bit like this, where these objects are talking to this model, and the model takes care of all the work in the memory store. So we've actually created the document model last time, and we also created the memory store. But when we look at our code, we have a bit more configuration because all we've done is create the memory store and the document model. We haven't done anything else. So we have to start moving how we configure that database to this new system. Okay, here we are in the Xrose document. Eventually, like I said, we're going to rename many of these things. So this is the old name, still working with. Now, if you remember, we actually create the document model inside the init for the document. So, and here that is. So we create that model, and we store that model up here. But notice what happens right after this. We have this function, or excuse me, this method called createDB. Let's take a look at that real quick. So this method is responsible for creating all the tables in the database. So you can see that we start with a SQLite statement, which is the actual SQLite call. We create a SQLite exec that takes the pointer to the document store, the statement, and takes a pointer to the error string. We see if there's an error or not, see if we get the SQLite OK back from the database. If we do not get that, we get an error, and then we present the error. So that's the user will actually see a dialog saying that there was an error and what the error was. Notice that we're doing the same thing over and over. Many times. This is more or less a violation of the drive principle. Don't repeat yourself. So that's one thing we want to get rid of, all this repeated code. And because it's repeated, we have a weird problem. If the database actually fails, it's probably going to fail for each one of these calls, right? So if it fails up here, this will likely fail. And then this will likely fail. And this will likely fail. And what that means is you're going to be showing the user failure after failure after failure after failure. So that's something that's not handled very well. Now, what might be a little hard to see in here because there's so much repetitive code is that in some cases, we're actually setting values as well. So we have a couple of places where we're doing something like this. If we have a window controller, we are calling this, we're calling this method on the main window controller by passing in the pointer to the database, and the window controller then will save some information to the database, which is kind of weird. If we look somewhere down lower, if I can find it, we do something similar right here. Again, if we have window controllers, we set, again, this particular type called a geometry controller, we're telling it to set its initial values to the database. Kind of weird. But you know what? Let's do the first thing. Let's prevent ourselves from repeating ourselves too much. Let's go ahead and pull this code and put it in the end. We can get rid of that. Now, if you think about it, it's pretty clear why those two functions with the same if check are done, because this was done one piece at a time, and it was realized that, oh, once I have this, and if I have a win controller, I need to save that value. But realistically, we only needed to do that check once further down. So we can just unify that and put it to the end so we know if we choose not to handle this in this episode, we can handle it down the road. Now keep in mind there's a lot of warnings here because we deprecated getting this store. So we're trying to show everywhere in the code when we should not be calling for the SQLite store pointer. So we'll see that quite a few places, and this will give us an idea. Now, a couple other things. I'm pretty much convinced that this code down here at the bottom isn't being used. Now, it's possible that I might want to recreate this code at some point in the future, but chances are it's not going to be Objective-C anyway, and I'll have to rewrite it. So let's just go ahead and get rid of this unused code. And finally, one other thing I've noticed about the document, I can bring up again later. I'm going to leave it as it is. But one of the things that confused me is that there seemed to be a number of methods in this class that the class doesn't really respond to. For example, awake from nib. In this document, I don't think actually responds to awake from nib. So it's been confusing me why it's there. It turns out this function is being called from the window controller. So when the window controller goes through awake from nib, it calls this in as awake from nib. So that's an example of really bad naming. There's no reason to use that naming in this particular way. So I had some confusion about why some of the things were being done, and it was because of the name. And so it's very difficult to come up with good names consistently, and this is an example of you have to be careful with how you name things because it will just confuse yourself down the road and confuse others. At this point, if we go to our document model, we see it's very simple. It doesn't actually do anything with SQLite except for keeps track of the memory store, and it will allow you to pull the pointer for the database for all those places that are now deprecated. So we want to deprecate. So we've already deprecated all this, and now we just want to make sure that we are aware of that wherever it's being called. But the real work in the SQLite is going to have to take place around the InMemory store. And that brings up an interesting question. Do we really want to do most of this SQLite calls here, or do we want to do something a little bit different? And one of the main things you can do is you can peruse the CocoaPods or Swift Package Manager libraries out there to do SQLite. And there's plenty out there that are pretty good. So you have to be a little bit careful about the different libraries you pull and try to use, because a lot of them are opinionated in very subtle ways that will make it somewhat difficult to swap to a new one. But I'm going to probably do the wrong thing here, and then I'm going to create my own SQLite piece of code. If you're probably unaware, but I have my own SQLite library called Codable SQLite. That library is designed to do a SQLite request, and it will be able to respond by returning actual types rather than dictionaries or whatever. It will actually use the Codable functionality in Swift to take those results and populate an array of items, an array of types. Now, I mentioned that sometimes these CocoaPods and Swift packages tend to be opinionated, and it turns out that mine was really opinionated in probably the wrong ways and in ways that won't work here. For example, it was very async await, and it was also not designed for InMemory stores. So I'm going to take some of those elements out of my Codable SQLite and bring it into here. But what I'm going to do is I'm going to create a separate submodule and build it from there. So I'm not going to get into the details of everything that goes into that submodule, but I'm going to start bringing that stuff in now. At this point, I've went ahead and added my SQLite code as a separate module to the application. If you look down here, I have Codable SQLite non-thread, kind of lingo for saying that this is a separate version of the other version of SQLite I have out there, Codable SQLite that I have out there. This one is a little bit different. That allows me to both read and write. The previous one was around the narrow idea of simply reading data in using Codable features in Swift types. And I went ahead and added into the document each type, one representing a table in the database. window controller size, the geometry, the layer, general layer, a color, a data set, and so on. Now, each of these types have some specific features. One, they have all the fields listed as a property. Also has the table name. If there's a primary key, it lists what the primary key is. And it has a bunch of queries that are designed around updating the database or reading the database. Now, at this point, I'd love to go on and start changing my code around, but first I want to do something that's kind of annoying to me. So if we look, let me go ahead and run tests and see if we can get it to run. Oh, I have a little error there. What do we have? It's missing a parenthesis. Hopefully that will fix it. Oh, and as a side note, for this new module, I've actually used Apple's new Swift testing library instead of XCTest to write the unit tests. We can talk about unit tests later. I just want to go ahead and move things forward. Now, when we look over here, we see a number of warnings. Some of these are expected. For example, the store is deprecated because I intentionally put that one in there so we can find all the places where we need to stop using this store. And we see again some errors here and there, or warnings here and there for old style UI. These are all things that we're kind of aware of. But now we start getting into some SwiftLint errors that are kind of annoying. This one's annoying because it's a good idea not to use magic numbers, but in unit tests, I feel like they kind of are fair game in unit tests. Not so much in main code, but unit tests here. Sure. However, I don't really want to turn it off, but I think we're going to have to turn that one off. And the second one that annoys me is this one here, this number separator thing. I understand why people like to use this underscore as a number separator in a number. So in other words, instead of looking like this number with 23,212, it looks like this. I happen to not like that because it's a lot of extra typing. If I need to, I will do that if it's unclear. But most of the time, I don't want that. And I definitely don't want warnings inside of tests for that. So these two things, number separator and no magic numbers, I'm going to go ahead and turn off. Something else here. And we want to fix that as well. That one's one we want to fix. And there's one other problem with line length. I'm getting a lot of line length errors. I don't mind line length warnings, but I really don't like line length errors. So let's do that. Okay, here I am in code. And I've added this condition on line length. Changed the warning to be a little bit more sensible and also trying to ignore some things that might be a bit longer and sort of prevent the errors. Because the way the base configuration of line length will work is that it will actually throw an error in building and you can't move forward. I just don't want anything like that to interrupt my flow. Warnings are fine. Errors should be real errors. The next rule we want to take a look at is no magic numbers. So eventually this one might be turned back on. It can be actually disabled if the parent class is an XCTest, for example, or some other class. But I'm moving to Swift testing, which doesn't use classes at all for the tests. So I'm not sure that this is ready for being turned off just for test yet, but sometime in the future it might be. So next, I want to turn off the number separator. There it is. I might turn that back on in the future, but right now, I really don't like it. I find the underscores distracting to type. They're kind of nice to read, but they're very distracting to type. So I'm going to just turn that off for now. There's also one other group of things I want to look at. So if you look these up, this is a different way of handling expectations. You bring in this Nimble framework and you can have a different way of making assertions. So right now, I never really needed these. I was using standard test assertions, and now I'm using Swift testing assertions, and I'm probably not likely to adopt Nimble in any time in the future. So just double checking to make sure I've turned these now off. Okay, those are now turned off. So let's go back to the project and do tests again. A lot of these warnings have gone away. We still have some. This one's fair enough. I can make this a little smaller. And I like to have a particular format when I do these, like this. So that line length is done. I don't know why that keeps cropping up, but it does. I'm suspicious that this is being formatted by something else. We'll see what happens. So right now, I'm not seeing any more of these SwiftLint problems. Let's run it again. Aha, so that is the same place, and it got reformatted again. I'm not sure why that's happening. So this is undoubtedly a conflict between SwiftLint and SwiftFormat. So this is something I'm going to have to fix in the future. But I'm not going to fix it right now. It's just a slight annoyance. So now that I got this mostly cleaned up, I'm going to head and make a commit. So you can see that we set ourselves up by moving these particular SQL calls to their corresponding tables or table types. So the next thing we need to do is accumulate all these table creation queries and then execute. If you remember in the last episode, we created the InMemory store. As you can see, it's directly talking to SQLite and creating the store. But now we have this module that can do that for us. So what we're going to do is swap all this out. Okay, this was a really quick replacement. So now instead of using SQLite to create the store right here, we're actually using our module. We are asking for the store. Whenever we ask for the store, it checks to see if the store exists. If it doesn't, we create a store. We return the store. And then if it fails, we return a nil. If the store already exists, we then return the store. Right now, this is relatively simple. It's not perfect, but at least it gets us started. One thing, though, is that we're still controlling the store. So we need to make sure that we properly handle it. So remember, I deleted this because it wasn't working because the SQLite store is being closed here. But what we might decide to do, though, we can discharge that change, and we could set this to nil as a possibility. Because we never really closed the store. Let's double check to see if we have an interface, a way to close the store. So we do. So we should be calling this instead of doing nothing. So let's go back here. Now this is going to be optional, so let's do of course we need to throw it or do error checking here. So in this particular case, we have the try catch set up, but we're not going to be able to pass this one up. So if it does error, we need to print it at the very least. Now I think I may have created a logger, but we can go back and check that. Let's build and run and see what happens. What we're going to be looking for in our run is for any of these errors to show up. Okay, I don't see anything, so that means we've likely created it. But let's go ahead and just make sure we're hitting this particular set of functions when we create a document. Let's load it up, run it. We're creating the in-memory store. No problem. Let's see if we're accessing it. And we are definitely accessing it. And we're accessing it a lot, as we'd expect. All right. Good. So now we've successfully moved this over to this SQLite interface. Now it is a struct. We can probably just create one and hold on to it. So let's create that. Now we can just replace that with our interface. Now eventually what I want to do is replace this with a protocol. So as long as it has these functions, we can use anything for this interface. In fact, we'll probably want to inject that when we create the in-memory store. But for now, we'll just leave it this way. Next, now that we have this here, we want to be able to do what we originally intended to do. Let's go back and refresh our memory one more time. And it is this function. So if you remember earlier, we took out a couple of bits and pieces here, moved it to the end of the function. Down here, but we wanted to move all these things somewhere else. So what we're doing here again is we get a SQLite query, perform that query, get the error, and if there is an error, we present it. As I mentioned, this creates a problem because if you're going to have an error in one, you're probably going to have error in all of them. Therefore, you're going to get a whole host of errors. It's not what we want to do. Okay, so that means we need to get all of the statements together and call into the SQLite interface to perform all those statements. Now, if you remember, I created a set of models for each of what I call the application tables, tables that are supporting the application directly and not user data. So these are different layers, different parts of the app that I want to store off information. Again, we'll probably completely change this somewhere down in the future, but as of right now, we need all of these. So if we look, the way I set this up is each one of these layers are a table representable type. And inside there is a create table query. So this is the same text, more or less, that we had in the other part of the app. So we can create basically a list of all these things all together so we have one particular set. So count isn't actually a particular table. It's something I might remove because I added a similar feature into the module. But now we have a way to get all the queries together into a single set. Okay, so this is really expecting a protocol. So now we have it all wrapped up together in a single one. So a little bit of reorganization. This is actually a public function. This is a private one. So let's move all the private stuff down below. Okay, so let's configure the store here. I tried it once and I actually messed it up, so let me try it again. So first off, I want to say guard SQLite store else return. I'm not going to throw in this case because the store is already should have thrown an error. But now we can say the create table queries. Weird. This should probably have a throw. Yep, so try. And that will require a try as well. Okay, so what we're doing here is we're making sure that this value is not nil because we need to have SQLite store to be able to actually execute these queries. Then we want to go through our queries and then execute them on that store. At this point, if it fails, we'll throw. So we're not going to handle presenting the error to the user here. We're just going to simply throw the error and let somebody else who's talking to the interface pay attention to that. So if these are all successful, these will not throw. Now, I did make this private. This is not something anybody else should be calling. but it should be called probably whenever we try to create the store. And I think we only do that at this point. So try configure store. So now we can fail here or we can fail here. Either way, we're in a bad state and we need to handle dealing with this error. So now that we've done this, what we don't want to do is have the document call all this stuff. So let's go back here to the document. I'm just going to comment out I can comment that out too. Let me see if I can. Yes. So let's comment out all of that. So all that code is replaced by what we have now. Let's see what happens. So we managed to create all this. We didn't get any kind of errors. So it appears that we were successful in creating all the tables. No throws, no log. So in theory, we can now delete all of this code. In the process, we get rid of a lot of warning. So that was the main goal of this work for today, was to be able to delete all that code. Now our document code is down to about 600 lines. But I don't know about you, but I'm not really all that comfortable with what we just did. And the reason why I say that is it looks like it worked. It seems like it worked, but I don't actually know fully that it did everything that I expect. And why is that? Well, because I didn't write tests. I mean, if I build and build and build and add more to the app, I'll know more and more about whether or not that code all worked. But right now, I don't actually know. It seems to work. The only really good option at this point is to write tests. And arguably, if you like TDD, you should have written the tests already. And I pretty much skipped that. It is a very simple interface, but I can't actually answer the question of did any of this work in the way I expect. So I may not show writing tests around all this code, but I am going to be writing tests for it. It's kind of a necessity. I just don't feel comfortable that I know this is truly working. It seems to work. I can get rid of that. Get rid of that warning and just get rid of this warning. It seems to work anyway, but I don't actually know. And if I built onto this, it's only going to make the problem a little bit worse. And I mentioned earlier that we may want to inject a SQLite interface rather than just creating it here. And that's another sign that because I didn't write tests, I didn't build this particular object with testing in mind. Because what I should be doing is injecting this interface. but I'm not doing that. So the fact that I wasn't testing has made this code harder to test. So off camera, I'm going to work on tests, and I'll probably summarize the changes that I made next time for writing the test, but I'm not going to go over this particular set of tests for this piece of work. I am going to test it though. I will probably in the next couple episodes actually just talk about testing in general, have just a conversation about that, because I think there's a lot of interesting discussion going on the internet that some people say, don't unit test, don't do this. And some other people are saying, absolutely do all these things. And it extends not only to testing, but certain kinds of patterns to use and that sort of thing. There's always these big discussions about when you should be doing something versus when not to be doing something. And any absolutist out there is probably wrong. Anybody who says don't do this or always do that, they're wrong, period. There's going to be a range of thought around each of these things, and very context driven decisions will be made. So we're going to talk about that in a future episode. But as of right now, I think we're at a good spot. I might look around for any more warnings to see if I do anything else, run tests while I'm at it. And I think that's it for this episode. Be sure if you like what you're seeing, you like trying to understand what I'm doing, like and subscribe. But if you have any questions or comments, also leave comments about what I'm doing. You may totally disagree with what I'm doing, and that's fine. Start a discussion. I'm doing this in part not only to share what I know, but also to learn from other people. So if you have thoughts, go ahead and write them down. I'd love to see them. Until next time, my name's Tom.